Alright, welcome back to 5.6. This is the last lesson in Unit 5. Okay, so we're almost done with Unit 5. We're going to be talking about cosine law. And last time we talked about sine law, and we're going to be talking about cosine law today. Because for sine law, there are some triangles, some situations where we're not always going to have pairs, right? So we might need to come up with different ways of solving an oblique triangle, and cosine law is going to help us with that. Before we start, here is the question that you could solve with sine law, so I'll let you try it, and I'll show you the answer in a bit. Okay, so this is what you get. We can figure out what angle B is first by taking 140 degrees and 25 degrees away from 180. You end up with 15 degrees. Once you know angle B, you can solve for length B by setting up again the sine law equation. Cross multiply, you should get 8.1, and you can do the same thing with length C. Again, set up the sine law equation. You should get 13.1 for C. Okay, so again, the key thing for using sine law is that you must have a pair. Okay, sometimes we don't. Okay, so then in that case, sometimes we get the pairs, but we don't have angles, other angles. So we might need to use a different rule, and I'm going to show you cosine law right here. Okay, so again, given an oblique triangle, so something like this, we have angle A, angle B, angle C. Here's side A, side B, and side C. Cosine law is written as, or is defined as this: C squared is equal to A squared plus B squared. So notice these are lowercase ABCs, so they are side lengths. Okay, so C squared is, notice this is the Pythagorean theorem, but not quite. We have something more that we need to write down. It's minus 2AB cosine of C. Okay, so this is the cosine law. Okay, so again, C squared is equal to, obviously you can interchange these side lengths. So for example, you can write this as A squared is equal to B squared plus C squared minus 2BC cosine of A. Okay, so you can just interchange any of these sides or angles. That's fine, it's gonna work. Okay, again, this angle, this is capital C right here, so this is the angle, that's the angle. The rest will be side length. Okay, well, might as well, I'll write down for B squared as well. B squared then would equal to A squared plus C squared minus 2AC cosine of angle B. Okay, so these three are really talking about the same thing. Okay, you're just looking from a different angle, that's all. Okay, so here's the example. We are looking for the length of QR to the nearest tenth. So you can see this case, you just can't find a pair, right? To use sine law, you either have to know this angle this side length and this angle, or this side length and that angle, or this angle and this side length. But none of them match up, right? There's just no pairs. So in this case, we have to use cosine law. So this is length QR, or just P. Okay, so this is like our missing side, and this is the angle that we know. So these two, the P's, are like the A's here, or the C's here, or the B's here. So I'm going to say P squared should equal to the other side squares added together, minus 2 times 10 times 17 times cosine of 31 degrees. Okay, now this is a long equation. Okay, it's a lot of calculations here. I would suggest you to do it step by step on your calculator to avoid mistakes. 10 squared is 100. 17 squared, I believe, is 289, but I'll just double check. 289, yes. Minus 2 times 10 is 20. 20 times 17 is 340. You still have times cosine 31 degrees. These two can be added together. That's 389 minus 340 times cosine 31. This is 291.4. Okay, Now, when you put this into calculator, make sure you use the answer button on the calculator, okay? Don't actually, use 291.4, okay? Make sure you utilize the answer button on the calculator. So then you go 389 minus the answer, and you should get 97.6, and then you can square root both sides. Then you get, let's see, so square root answer, you should get 9 point, nearest tenth, so 9.9 centimeter. Okay, so that's how you use cosine law. Again, what you need to do is you're also looking for a pair. But instead of a pair that's already both solved, you're looking for a pair that's missing one piece of information, okay? So here is a question for you to try. See how you do. So again, here is the diagram, okay? Here's triangle STU. We are again looking for the pairs, okay? So this is the pair. Again, we have one piece of information that's missing, right? We're looking for this angle, but we don't know what that is. So this is the pair, okay? So that tells us 20 is C, okay? So we have C squared is equal to A squared plus B squared minus 2 times A times C times cosine of angle T. Okay, so now again, we are going to do step by step. 200 squared is 400. That's 36. 16 squared is 256. Minus 2 times 6 is 12. And then we go 12 times 16. This is, what is this? 12 times 6, I think it's 192. Just let me, yeah, it is 192 cosine T. Okay, now, again, these two can be added together. This is simply 400 equals 292 minus 192 times cosine T. We can then move 292 to the other side. So minus 292 minus 292, you should get 108 is equal to negative 192 cosine of T. Now you need to divide both sides by negative 192. So you end up with negative 108 over 192 is equal to cosine of T. All right, now here is a situation you got to be careful, okay? Once you get here, I actually don't know what's going to happen if we just take the inverse. So I'm going to try it first and see what happens before I say anything. Okay, actually, it's fine. So once you get here, you can solve for T by taking the inverse cosine of negative 108 over 192. Then you should end up with 124 nearest degree, so 124 degrees. Okay, so that would be it. Yeah, the reason why I hesitated was because I'm not sure. Well, I think it's always going to give you the answer in second quadrant, so I think it's fine. So don't worry about it, okay? So once you have this equation, you can take the inverse. You should get 124 degrees. Okay. So hopefully these were just solving the triangle question. So hopefully it's not too difficult for you to use or to understand how to use cosine law. Next page, we're gonna solve some word problems, okay? So here it says a retaining wall is leaning at an angle of 70 degrees to the horizontal. So here's horizontal. We have a wall that's leaning towards the horizontals. This is 70 degrees. Well, it's falling down, so we must have a support, right? So it says a rigid support is to be placed 5 meters from the base of the wall. So let's say here's the rigid, here's the support, and let's say this is 5 meters. And it will be attached to the wall 2.5 meters away from its base. Okay, so here is the support, and this is 2.5 meters, right? This is attached to the wall that is 2.5 meters away from its base. Here's the base of the wall. So this is 2.5 meters. Again, the diagram is not drawn to scale. Determine the length of the support, so we're looking for this. To the nearest tenth of a meter, and measure of the angle between the support and the wall. So we are also looking for this angle. Let me call that theta. Okay, so first of all, let's figure out x. So you can see x is one of the pairs, right? Or it's part of the pair, right? X and 70 degrees. Again, this is a pair, but x is missing. So we cannot use sine law, we have to use cosine law. So that means this is going to be our c. So x squared is equal to 2.5 squared plus 5 squared minus 2 times 2.5 times 5 times cosine 70 degrees. Okay, we can put this into a calculator and see what we get. That's 6.25. This is 25 minus this is 25 times cosine 70. Okay, so then this is 31.25 minus, now I need to put this into a calculator. I have no idea what this is. And this looks like around, again, 8.55. However, again, you do not actually punch in 8.55 on the calculator. You use the answer key button on your calculator to get the exact value, or at least not rounded. This is 22.7. And then now I'm going to take the square root of the answer. And I get, we are rounding to nearest tenth of a meter, so 4.76, therefore 4.8 meters. Okay, so we know this is going to be 4.8 meters. Okay, now once we solve for x, we now have a pair solved, right? This is 70 degrees and this is 4.8 meters, which means we can now use sine law because we have a pair. So then we go 4.8 meters divided by sine of the angle 70 degrees. This should equal to, we're looking for angle theta, and the pair for theta is the 5 meters. So it's going to be equal to 5 over sine theta. Cross multiply, you should get sine theta is equal to 5 sine 70 degrees divided by 4.8. And to find angle theta, you simply take the inverse sine of whatever that's on the right. And now you need to put this into a calculator. Okay, and let's see what we get. 5 times sine 70 degrees divided by 4.8. What? Okay, let me try it again. 5 sine 70 degrees divided by 4.8. And then we take inverse sine of that. 78 degrees, nearest degree, so 78 degrees. Okay, so that's how you do it. The key thing is to draw the diagram, okay, and then figure out which rule we need to use. Do we need to use sine law or cosine law? Again, sine law if you have a pair already solved. Cosine law if you have one part of the pair that's missing, right? You have some missing information from that pair. Then you probably will need to use cosine law. So basically, if you cannot use sine law, then you probably need to use cosine law. I mean, what else can you do, right? All right. So, okay. So before we do example 3, there's a couple of things that you need to recall, and there's something new that we need to know. Okay. So you can see from the diagram, it says angle of depression. So you need to know what that is. Remember, angle of depression, and there's also the angle of elevation. Both of them are actually comparing with the horizontal, okay? So if we have a diagram that looks like this, okay? This angle would be angle of elevation if you're looking from the ground, right? Because that's going up. This is a tower, and someone is standing, on top of the tower or on the deck of the tower. If you're looking down, then you have angle of elevation. However, you got to be careful. The angle of elevation is not this one right here. No, it's not. It's actually right here. This is angle of depression because it's comparing again against the horizontal line. So this is angle of depression, not this one. This one is not an angle of depression. And this is angle of elevation again because it's comparing against the horizontal line right there. So this one is looking up and this one is looking down. So that's angle of elevation and angle of depression. This is elevation, and this one right here would be depression. Okay, so that's the first thing you need to know. Second thing here is the bearing of 0, 90 degrees or the bearing of 200 degrees. So bearing, okay, it's again a way to talk about direction. When we have a bearing of some angle, it means you're looking from north and you're rotating counterclockwise. No, sorry, you're rotating clockwise. Okay, I was picturing how does the clock rotate, the second hand. So you're actually rotating this way, okay, clockwise. So here's the question. It says from the top of a 30-meter observation tower, a fire ranger observes smoke on a bearing of 90 degrees with an angle of depression of 2 degrees. The ranger spots more smoke on a bearing of 200 degrees with an angle of depression of 5 degrees. To the nearest meter, how far apart are the source of smoke? Okay, so now I'm going to show you how I'm going to do this question here. This is 3D, as you can see from this diagram here. So what I'm going to do right now is I'm going to break this 3D diagram into two 2D diagrams. Okay, so you can see we have two triangles here, right? This is the height of the tower. This is 90 degrees on a bearing of 90 degrees. Okay, and that means we have this triangle. The height of the tower is 30 meters. And the angle of depression is 2 degrees, so this is 2 degrees. So this is our first triangle. The second triangle is this one right here. Okay, and if I draw it, maybe I'll draw it like this. Okay, and this right here is 5 degrees. And again, I know the height of the tower is 30 meters. And we are actually looking for, what are we looking for actually? How far apart are these, are the source of smoke? So we're actually looking for this. We're looking for that distance. Okay, so that means I have a third triangle actually. So now I have this triangle. And we're looking for this. Okay, so now what we can get out of these two triangles is we have this being x, and this x really translates to this x here, right? That's also an x. And this length of y right here, that's this part, that is the y over here. Now what we need to figure out is, well, I guess we need to figure out x and y first. Okay, so we'll do that first. So to figure out x and y, we have a triangle here. We can simply use SOHCAHTOA for this question. Now here it says this is 2 degrees, okay? So if you remember your angles properties of parallel lines, because this is horizontal, this is also horizontal. If that's 2 degrees, this is also 2 degrees, okay? If this is 5 degrees, this is also 5 degrees. This is called alternate exterior angles. Or is it no? It's alternate interior angles. Okay, it's the Z rule. Okay, so here's 2 degrees. We have opposite side being 30. We're solving for the adjacent side, so we must use tangent. So we go tangent of angle 2 degrees is equal to opposite side was 30 over x. So x is simply 30 divided by tangent of 2 degrees. Again, you can cross multiply and solve. 30 times 1 is 30. You have x times tangent of 2 degrees. You know what? I'll show you everything for this time. X tangent 2 degrees is equal to 30 times 1 is 30. Therefore, x is equal to 30 divided by tangent of 2 degrees. We can put this into calculator. You get 30 divided by tangent of 2. This is 859.1. Okay, and that's meters. Okay, for y, you do exactly the same thing. So you go tangent of 5 degrees is opposite over adjacent. So now you can see y then is going to be 30 divided by tangent of 5 degrees. And if I put that into calculator, I will get 342.9 meters. So now I can actually write x and y here. I can actually write numbers instead of x and y here. 0.1, and this is 342. 0.9. Now we're looking for this side length. That means we have to use cosine law because we're looking for the third side. We just need to figure out what this angle is, okay? So this is the angle between, okay, so what I'm gonna do right now is I'm gonna draw this. So here's the tower, okay? It says on a bearing of 90 degrees. Maybe I'll do it here so I don't need to erase it. I'll do it in a different color too. Okay, so here's the tower. It says the first smoke is on a bearing of 90 degrees. So here's the fire. And this is 90 degrees. And it says the other fire is on a bearing of 200 degrees. So if you rotate 180 degrees, it's going to be right here. And 200 degrees means somewhere there. So here is second fire. Okay, this is 90. This is 200. That means this angle is going to be 200 minus 90, which is 110 degrees. Okay, hopefully that makes sense to you. Again, this is on a bearing of 200 degrees. This is on a bearing of 90 degrees. Therefore, whatever that's left is 200 minus 90, which is 110. So this is 110. Now we can use cosine law, right? So this is something that we don't know. Let me call this x. Maybe not x, we use x already. Let me call this z. So z squared is going to equal to 342.9 squared plus a 59.1 squared minus, okay, I don't have enough room to write this. I'll write it down. Next line here, times, minus 2 times 342.9 times a 59.1 cosine of 110. Okay, so I'll let you try to work this out because I don't really have enough room to show all the steps. I'll just write down the final answer in a bit. Okay, so this is what I got, 1028.2 meters, but it asks us to round to the nearest meter, so it's 1028 meters. Okay, again, plug into your calculator step by step, okay? Don't need to rush. I think that's what you should get. Okay, so this is a 3D problem that we broke into 3 2D diagrams, and then we can actually solve this problem right here. This is very much similar, so I'll let you try it, and we can compare answers in a bit. Okay, good luck. Okay, so here is what I got. My final answer is 42 meters. One thing you need to notice here is it says David is due north of the tower. So I drew this as north, and because it's due north, and so here it says when the bearing is 175 degrees, it really is counting from, again, from the north, right? So if that's north, then this right here would be 175 degrees, and that's why I have 175 here. So this question is slightly easier than the previous one because we don't actually need to figure out what this angle is. It's kind of given to us in a way. But you need to know bearing, again, means from north and then rotate clockwise. And then once you have this, the steps are pretty much the same thing as the example there. You should be able to get 42 meters. Okay, so that's it. This is cosine law. There's no tangent law. So we're done. This is it for trigonometry this year. Do some practice questions, do your review questions for this entire unit. Let me know if you need help. Good luck.